In this video, we will clean the inside shape using 2D high-speed dynamic contour. 2D high-speed dynamic contour toolpath utilizes the entire flute length of the cutting tools and is used to mill material off walls. It does support both closed or open chains. Select Toolpaths, 2D high-speed, dynamic contour. When the chaining dialog box appears, enable the partial button as shown. Select the following entity. Ensure that the arrows are pointing downwards, otherwise choose the reverse button shown here. Next, choose the following entity. Once complete, select the OK button to exit the chaining dialog box. When the Chain Options dialog box appears, leave the Single Region option as shown. You can now select the OK button to exit the Chain Options dialog box. From the Toolpath Type page, choose Dynamic Contour and then select Tool from the Tree View list. From here we will select the 1/16 inch tool. To do this, choose the Select Library Tool button and then the Filter button. Now choose the None button and then under Tool Types, select the flat end mill icon. Next, under Tool Diameter, pick Equal and input a value of 0.0625 as shown. Once complete, select the OK button to exit the Tool List filter. In the Tool Selection dialog box, you should now only see a 1/16 inch flat end mill. Select this tool and then choose the OK button. Your tool will appear as shown. Input the following comment as shown. Once complete, select the cut parameters. Make the following changes. Ensure that the approach distance is a value of 0.25. Also, change the amount to leave on both the stock and walls to 0. And finally, change the percentage of tool diameter to 500. I will now take a brief moment to explain a few of the parameters on this page. Compensation direction offsets the tool to the left in this example. Approach distance adds the specified absolute distance to the beginning of the toolpath's first cut. Step over sets the distance between cutting passes in the X and Y axis. Enter a percentage of the tool diameter or an absolute distance. Min toolpath radius sets the minimum toolpath radius used in combination with the microlift distance and back feed rate parameters to calculate 3D arc moves between cut passes. Once the parameters have been adjusted, select Contour Wall. Make the following changes. Ensure that the radius of tool that shaped the stock is a value of 0.125. The radius of tool that shaped the stock is the radius of the tool used in a toolpath that already cut this area. Mastercam calculates the stock to remove along the contour wall using the stock thickness, and, if provided, the radius of the tool that shaped the stock and the toolpath radius that shaped the stock. In our case, from the previous contour operation, You used a 1/4 inch flat end mill and no toolpath radius. Once the parameters have been adjusted, select the depth cuts. Enable this option and input a max rough step of 0.05. Also, input a finished step value of 0.05. Next, select Breakthrough, enable this option, and input a breakthrough amount of 0.1. Finally, choose the linking parameters. Input a depth value of absolute negative 0.125. The rest of your parameters should appear as shown. Once complete, select the OK button to generate the toolpath. We will now backplot and verify the operation to ensure that the tool motion is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled. Now select the isometric view and Fit icon. Press the Play Simulation button to run backplot. Your toolpath will appear as shown. You can now exit backplot. From here, select all of the operations and verify your part. Ensure that Tool, Stock, and Workpiece are enabled. Now select the isometric view and Fit icon. Press the Play Simulation button to run verify. Your part will appear as shown. You can now exit verify.